Okay, so we have the bearing from A to C is uh, north 64 degrees west. The bearing from A to B is south 82 west, and the bearing from B to C is north 26 east. A plane flying 350 miles an hour takes 1.8 hours to go from A to B. Find the distance from B to C. Okay, so really the whole trick to this is getting the picture right. Because they gave us two directions, we are going to draw a north-south line. So here's my north-south line. It's supposed to be straight. It isn't, but it's supposed to be. And here's point A. So the bearing from A to C is north, so this north-south line, and then it's 64 degrees west of north. So west is to the left, so I'm going this way, and this is 64 degrees. And out here, this is C, okay? Then my next one, bearing from A to B, is 82 degrees southwest. So now I'm going south, so I'm going down, but I'm going west, so I'm still going to the left side. Because remember here, north, east, south, west, never eat soggy worms. So this way, here out to here, to B, this right here, this is 82 degrees. Okay, so we start from this north-south line. In this case, we're on the bottom going west because we're going south, and the top because we were going north. We're still going west, but we're going off to the top. That's how we tell the difference. Then the bearing from B to C. Okay, so I have to draw another little north-south line. So I've got both of these are straight parallel lines. So the orange dotted line and the purple dotted line are parallel. It's important to remember here in a minute. And the bearing from B to C. So as I'm going back here, this is 26 degrees east because I get I'm north, but now I'm going east, so I'm going off to the right, but I'm starting at that north-south line. Had this been west, I would have been going the other way. If it had been south, I would have been down the bottom, but obviously this makes sense to us. So each one of these points, we're starting from a north-south line, and that's how we're distinguishing which way we're going. Now the other piece of information we're given is this right here. A plane flying 350 miles an hour takes 1.8 hours to go from A to D. Well, distance, I need to change back to something we can read. Distance equals rate times time. So then distance equals 350 times 1.8, which gives me 630 miles. So the distance from A to B is 630 miles. I want to know this out here, B to C. The first thing I need to do, though, is I need to figure out where my right angle is, if I have one. And I hope I have one, because at this point, that's what I need to figure this out. So I need to figure out, right now, I don't know any of the three angles of this triangle. My goal is to see if I can figure them out. So first, this angle A, C-A-B, okay? This is a straight line. Remember, A is a straight line. So then if I know two of them, the whole angle has to be a straight angle to 180. So 180 minus 64 minus 82, this is 34 degrees in here. Okay? Now, this angle 82 and this angle here, these aren't congruent. These are interior angles on a transverse. Remember, this is back from all our angle things. These also have to be 180. So 180 minus 82, this is 98. Why is that useful? Well, because then I know, again, that I have a straight line here, so that 26 plus this angle here, CBA, so this one right here, this CBA here, plus 98 has to be 180. So 180 minus 98 minus 26 gives me 56. Now this angle, triangle has to be 180, so 180 minus 56 minus 34 gives me 90. There's my right angle, okay? So I'm using those facts those geometry facts that we went over at the beginning in chapter 1, and I'm using those to figure out my angles once I have the picture set up. The picture is incredibly crucial here. You have to have it set up right, and part of it's reading the bearing. The method 1 bearing is a lot easier than this method 2 bearing because you have to keep getting these straight lines. But the beauty of those north-south straight lines is they're parallel lines, and you can then use all those facts from chapter 1 about alternate exterior and interior angles, about interior angles like we used here. You've got lots of choices on things that'll help you figure out the angles. Now, I want to know this. I know both of these, so I can either use, this is the, I am looking, this 630, this is my hypotenuse, so I'm going to probably want to use sine or cosine. I'm going to use sine, but it doesn't really matter, so I'm going to do the sine of 34 degrees is opposite, which is x, over hypotenuse 630. So then into my calculator, I'm going to put 630 sine of 34 degrees, which should give you 352.3 miles. But as we look back, we can see that all our miles were rounded to the nearest 10. 350, 630, so we're going to call this 350 miles. And that's our significant digits. So we can see here, this all came down to setting up the right angles so that we knew how to draw these. And it definitely is one of those. I usually, if you look at my notes of setting this up, I have 3 different versions. I draw it. I'm like, oh, I didn't give myself enough room on this side. I redraw it. I start over again. Kind of, and usually what I do, and a lot of times I try to start my first angle in the middle of the page, so I have ways to go either way, because I'm not always sure which all the different ways I'm going to go as I start drawing. But it's definitely important that you get that picture drawn. And then once you have the picture drawn, then okay, what can I figure out just based on what I have drawn? And you can see here we filled in all the angles by using our geometry facts. And that's really what you've got to do, because we needed those angles. We needed more information to be able to set up a trig equation. We knew we needed a right angle, and at this point, we didn't know we had a right triangle. We had to figure that out, and so that was part of our process.